Digits is a wrist-worn 3D hand tracker for gestural interactions on the move. The wrist-worn sensor allows the full 3D pose of the user's hand to be recovered in real time, while removing the need for wearing a data glove that covers the entire hand. The recovered hand pose can easily be used to recognize diverse gestures, even while on the move. Our system can be used in a variety of scenarios, including 3D gaming and augmented reality, where both discrete or continuous hand gestures can be used to control input. As the device is wrist-worn, no line of sight to an external sensor placed in the environment is required. The user can perform subtle gestures while resting their hands on their leg or table. Digits is built using only off-the-shelf hardware. The main components are a wrist-worn infrared camera, infrared laser line generator, additional diffuse infrared illumination, and an inertial measurement unit, or IMU. The infrared camera captures the inside of the user's hand under alternating illumination, the first frame without any active illumination. This captures only the ambient infrared in the scene. Next, a frame is captured with the diffuse infrared LEDs on. And finally, a frame with only the infrared laser line generator. Ambient infrared is suppressed by subtracting the unlit frame from the other actively illuminated frames. In this example, this leaves a clear image of the laser intersecting with the fingers. After thresholding the image, each projected laser line segment is separately tracked. Then, their 3D positions are recovered by triangulation. We use a seam carving-based approach to separate and identify individual fingers in the diffuse infrared image. These fingers can be associated with each triangulated 3D point. From these sparse 3D points on the hand, we can recover the full hand pose by exploiting the biomechanical properties of the human hand. In our first simple forward kinematics model, we assume that the MCP, pip, and dip joints are articulated proportionally during natural bending of the hand. From only the triangulated 3D points of the projected laser, we can derive all joint angles for each individual finger. For details, please see the paper. This already allows for a rich set of both discrete and continuous gestures for interaction. However, it also restricts how accurately we can reconstruct a 3D hand pose, as each joint angle cannot be modeled independently. A more realistic reconstruction can be achieved by robustly tracking fingertip locations. To achieve this, we model the light falloff from the infrared LEDs and generate a coarse depth and a normal map. While the depth estimate is distorted, fingertip locations can be clearly distinguished from other parts of the hand. We use a template matching technique to find fingertips in the image. Next, we propose an inverse kinematics model where both laser line segments and tracked fingertips can be used to more accurately model the joint configuration of each finger. Again, details are in the paper. This allows us to model the MCP joint angle and the pip and dip joint angles independently, and allows for truer hand pose recovery and higher degrees of freedom input. One interesting interaction possibility Digits enables is 3D spatial interaction around a mobile device that is seemingly interweaved with traditional touch interaction. Here, the user starts semantic zooming using an in-air pinch gesture and continuously controls the zoom factor with the remaining fingers. Another gesture is used for panning the interface or manipulating an object once it has been selected through touch. Another interesting design space for Digits is eyes-free interactions, where no visual feedback is required to control a mobile device. In this example, the user controls functions of a mobile device while the device is left in the pocket. Here, the user turns on the radio, switches channels by mimicking the turning of a dial, changes the volume by moving an invisible slider up and down, and finally answers a call by doing a thumb-up gesture. Digits can also be used for fine-grained 3D interactions, for example as a wearable gaming controller. In this example, the user mimics a gun with their fingers to shoot targets, and navigates within the virtual environment by performing a grabbing motion and moving the arm, and also selecting objects using hand gestures. We have presented Digits, a wrist-worn sensor that recovers the full 3D pose of the user's hand in real time, while removing the need to cover the entire hand of the user. Thank you.